Next up in this course on lighting essential concepts is dynamic lighting part 2, this time on outdoor lighting, which means we have to talk about CSM, cascaded shadow maps, distance fields, and DFAO, which stands for distance field ambient occlusion. The level is dynamic lighting _ outdoor, found in lighting _ rendering, essential concepts, start assets. Again, the same environment. This time, however, it has a landscape outside, so a bit of a couple of trees and with a distant environment, and we're going to use this to demonstrate dynamic outdoor lighting. Now, outdoor lighting is a little bit special because it has very specific demands. The fact that we should be able to see shadows far away is different than the requirement to see shadows in a small indoor environment like inside the apartment. So because it's so specific on what it requires and the impact it will have also on performance, because as mentioned in the previous chapter, dynamic shadows are very heavy. So if you have a very large open environment, that means you're going to see a lot of dynamic shadows and you're going to see them from very far away. So that's going to have a performance impact. And because of that consideration, we need to approach this a little bit differently here. So let's start with the basics. Let's add a directional light, and that obviously lights up the entire environment. We have something that simulates the sun. We're going to put the directional light to movable, so it's 100% dynamic. And then the result is this. There's a few things to note here. If you go inside the apartment or the house, there is no light bouncing at all, which is rather strange. I'll get back to that in a bit, but we're going to fix that with stationary, and that's going to continue on the previous chapter on dynamic lighting. But outdoor, we're going to primarily focus on the shadows. We can see we have actual dynamic shadows, as in they're following the animation of the trees. So the shadows are animated. They're not very particularly sharp, though. And also, if you would move away, eventually those shadows would fade out, as you can see. So these cascaded shadow maps, what it's using right now are cascaded shadow maps, CSM. This is automatically enabled on a directional light if you set it to movable and sometimes stationary as well, because of the settings over here in cascaded shadow maps. These are the shadows that are being used. So in order to overcome that performance challenge, it fades the dynamic shadows based on distance. So very distant geometry wouldn't be getting any shadows anymore to try to optimize this. You can change the range, and in fact the bigger the range is, the more imprecise the shadows are, and vice versa. So if this number goes down, the dynamic shadow distance, then the shadows will fade out faster, but it will also get sharper and sharper. You can see once I bring this down to say a value of 3000, and you look at the leaves again, they're a lot sharper. So the sharpness is driven by the range, but if I now move away, the shadows disappear a lot quicker. So that's the consideration. It's a balance you have to find. How sharp do you want the shadows to be vs how quickly do you want them to fade out? Cascaded shadow maps are called cascaded shadow maps because it literally does that. It cascades numerous shadows one after each other. That is why if you move away a little bit, you can see they got blurrier. If you move away even more, they got blurrier again. So it's essentially rendering 3 dynamic shadows, each of them with a different quality. One is high resolution, that's the one we have here. One is medium, one is low resolution. And based on your distance away from that shadow, it switches to the lower quality version, and again, in order to save performance. It cascades different shadow maps one after each other. The number of cascades it has is this value here, 3. So technically you could change it to 2, for example, and you would only have a single switch, higher quality to low quality. Now, you can mess with the settings, but usually you should just leave them be, especially if you're new to it. The most important thing for you to remember is the range and the fact that the shadows will fade out because of this value. But if you increase this too much, you will also lose all precision and you're going to lose probably performance. Now, because of that challenge, the fact that you're going to lose performance if you want to have shadows visible from far away, and you're going to lose precision, there is also distant field and distant field shadows. This has to be enabled in the project, otherwise it's not active by default. In this project that has already happened. You can see you're in settings, project settings, and if you look for distant field, you can see here it says engine, lighting, generate mesh distant fields. This is enabled. Again, this will not be enabled by default in every project. Once that is enabled, it will create a mesh distant field representation of every model. So you can go to show, visualize, and here it says mesh distant fields. If you enable that, you see the actual distant fields it makes. What a distant field is it is an approximation of the model that is stored in a volumetric texture. So it generates a texture for every model, and the texture acts as a volumetric texture, and it therefore approximates the model using that information, which is very imprecise, as you can see on the tree. Especially for things like trees, it doesn't work well at all. But it's enough for the shadows. So the shadows will now use the distance field information and not the model, the regular geometry itself anymore. That speeds up performance a lot. So it's an optimization, a way of optimizing the environment. You can see this in action is if you go back to the directional light and you set the, first of all, bring down the cascaded shadow map's dynamic shadow distance to a pretty small number so we can demonstrate it. And then secondly, there's a section called distant field shadows. If you enable that, let's do that. You can already see in the distance on the trees and the landscape what happens. They now have a shadow again. What would happen here is that you get high quality or fairly high quality cascaded shadow maps up close, but as the cascaded shadow maps fade out, which wouldn't be happening about now, they switch back to the distant field shadows instead. Let me bring down the range of this even more. You can see these are animated, that's CSM. You move away, these are no longer animated, that is the distant field shadows. These are much faster to render than these. So what we do is we use these up close and the distant field shadows in the distance to make sure that everything still has a shadow. It's simply a very blurry and imprecise one, but it doesn't matter because you wouldn't be able to see it from up close either way. So usually it's a combination of both distant field shadows and cascaded shadow maps for outdoor dynamic lighting. Now lastly, there is also DFAO, distant field ambient occlusion. I'm going to cover this more briefly because it is less important, and in this environment it doesn't work particularly well, I think. Distant field ambient occlusion is created by the skylight. So if you drag the skylight in, and in fact I'm going to temporarily remove the directional light just to show you what happens with only the skylight, and you set the skylight to movable, then you can already see the distant field ambient occlusion in action. It is this strange black shape over here. It works better in some scenarios than others. In this particular level it gets too strange. If you do have a large outdoor environment with a lot of dynamic lighting, I do advise you to experiment with it, and you probably want to keep it enabled. But again, here if you go inside the apartment, it is rather strange. What it tries to do is it tries to fake the bouncing of the light and the ambient occlusion of the light using distant field meshes. But since the distant field meshes are so imprecise, it doesn't always give you the best result. In the settings on it, it says here distant field ambient occlusion maximum distance. If you try to bring that down, it does look a little bit better in this level, and you can see what it attempts to do. It attempts to fake the bouncing of the light inside, even though everything is fully real time. But again, it differs project to project. Sometimes it does work pretty well, and I would probably keep it enabled. Now lastly, to wrap up, remember what we said in the beginning of this chapter is that if you have a directional light in the inside, it's really pitch black. If you were to set to stationary, again, you would have the best of both worlds. You would have a sharp, well-defined shadow, including an animated shadow from the trees, from the cascaded shadow maps, but you would still have light bouncing inside. And that's what you can see in the essential concepts, finished assets, and then the finished level of this chapter, dynamic lighting _ outdoor finished. See, it's the same setups as what we just had. But here you see in the inside we have very nice bounce lighting from the sunlight, and that is because the directional light has been set to stationary. So here's another example of when stationary is a good idea. Usually the sunlight should be set to stationary. So we've gone through how to use dynamic lighting in an outdoor environment. That means cascaded shadow maps. They will blend with distant field shadows in the distance for reasons of performance. And there's also the ability to use distant field ambient occlusion on the skylight, and as well as you should probably put the directional light to be stationary for best possible results.